The pressurization system for the Boeing 747-400 is similar to those of other Boeing airplanes. The system consists of two cabin altitude controllers, a cabin altimeter, two positive pressure relief valves, 6 negative pressure relief valves in the cargo doors, and left and right outflow valves. Two cabin altitude controllers A and B use ambient pressure and flight plan data from the FMC to control cabin altitude by controlling the position of the outflow valves. Each controller is used on an alternating flight basis. The outflow valves can be manually operated from the cabin altitude control panel. The two outflow valves are installed at the rear of the cabin. Two positive pressure relief valves prevent cabin overpressure. Should an overpressure occur, the valves open to relieve the pressure. The cabin differential pressure indication changes color from white to either amber or red if an overpressure occurs. And Pack 2 shuts down automatically until the pressure returns to within limits. The 747-400 freighter has two negative pressure relief valves in each of the forward and aft lower cargo doors and the side cargo door. The relief valves prevent a negative pressure condition which could occur if the airplane descends at a rate which is excessive for the cabin altitude controller. There is no crew alerting for this condition. The relief valves open automatically when the cargo doors are opened by the ground crew. Controls for the pressurization system are located on the overhead panel. The cabin altitude auto selector selects the primary controller commanding the outflow valves. The normal position permits automatic selection of controller A or B on alternate flights. These switches permit manual operation of the outflow valves. When either switch is placed on, the respective outflow valve may be manually opened or closed. By placing the outflow valve manual control toggle switch to open or close. A push-button switch alternately changes landing altitude control between auto and manual. The selection is displayed on the primary ICAS. Auto indicates the landing altitude is set automatically from the FMS. In manual, the ICAS advisory message, Landing Altitude, is displayed. In manual, the landing altitude may be set by rotating the landing altitude selector. For normal operation, the selection should be Auto. Restore landing altitude control to Auto. The pressurization system has several different modes of operation. Let's look at a typical flight profile as we discuss the various pressurization modes. The pressurization system automatically configures for takeoff and 3 flight modes: climb, cruise, descent, and then landing. During the takeoff roll, the controller starts the pressurization process. The outflow valves begin to close. This pre-pressurization process minimizes pressure transients during liftoff. After the airplane leaves the ground, the system transitions to the flight mode. The flight mode is divided into 3 phases: climb, cruise, and descent. During the climb phase, the controllers command an average cabin rate of climb based on the takeoff field elevation, the planned cruise altitude, and the airplane time to climb. The airplane transitions to cruise phase 2 minutes after level off. The maximum cabin altitude for cruise is 8,000 feet and remains constant during cruise. For a typical descent, the schedule begins at the FMC top of descent point. To calculate the descent profile, the cabin altitude controllers use landing field elevation, time to descend, and barometric corrections. The target descent altitude for the cabin is set slightly below airport field elevation. This ensures that the airplane lands somewhat pressurized. At touchdown, the cabin altitude controllers open the outflow valves slowly at first and then at a greater rate until the airplane is fully depressurized. After the outflow valves are fully open, the system transitions to the ground mode. There are non-normal ICAS messages associated with control of the cabin altitude, outflow valves, and control of landing altitude. If the cabin altitude climbs above 8,500 feet, the pressurization information displays on ICAS and the cabin altitude display turns amber. If the cabin altitude climbs above 10,000 feet, the cabin altitude display turns red and the ICAS warning message Cabin Altitude displays. If the cabin altitude cannot be controlled, descend to a lower safe altitude. The ICAS advisory message, Outflow Valve Left or Outflow Valve Right displays when automatic control of the outflow valve has failed or the respective outflow valve manual switch is on. In either case, the pressurization information pops up on ICAS. The affected outflow valve can be controlled manually by selecting the outflow valve manual switch on. When the outflow valve is in manual, on appears on the outflow valve manual switch. The outflow valve can now be opened or closed using the open-close toggle switch. Close the right outflow valve. As you can see, closing the right outflow valve caused the left outflow valve to open. In our example, the left outflow valve is now used to control the pressurization system. Further crew action is not necessary. The ICAS caution message, Cabin Altitude Auto, displays when automatic control of both outflow valves fails. The message may also display if both cabin altitude controllers fail or if both outflow valve manual switches are on. Because the automatic system failed, cabin pressurization must be controlled manually. Select both left and right outflow valve manual switches on. You adjust the cabin altitude by toggling the outflow valves open or closed. Open the outflow valves to set the cabin altitude to 6,000 feet. As the cabin altitude approaches the target altitude, the outflow valves should be closed a small amount to maintain a constant cabin altitude. Close the outflow valves a small amount. The ICAS advisory message, Landing Altitude, displays if the landing altitude information from the FMC disagrees with the controller landing altitude.